In example 2, we've got a toy train travelling along a track, and we know it's a straight track and it leaves the start of the track at t equals 0, and then it returns to the start of the track again. And what we've got is we've got the distance s meters is given by this equation here. So what this tells us is for a given value of t, we know the displacement of the train from the start of the track. And we've also got this condition here, which says that t has to be between 0 and 4. So we're asked to explain why we have that restriction between 0 and 4. So let's try and work that out. It's often useful to try and draw a sketch of the displacement time graph. So let's do that. First of all, when we sketch this displacement time graph, we know that it's a negative cubic because the coefficient of the t cubed term is negative. So let's just remind ourselves a negative cubic has a shape that looks like that in general. So let's try and find the roots of this graph. So when t equals 0, when s equals 0, we're going to solve 0 equals 4t squared minus t cubed. Let's take out a factor of t squared, and we're going to have 4 minus t inside the bracket. So here we're going to have t squared equals 0, or 4 minus t equals 0. So here we're going to obviously get t equals 4, and here we're going to get the solution t equals 0. Now remember, a cubic should have 3 roots, but here we've only got 2. That's because the t equals 0 root is a repeated root. So we'll bear that in mind when we're sketching it. And it's repeated because we've got t squared equals 0, so we get 2 roots from that, but it's just 0 repeated. So let's draw our displacement time graph. We put t on the horizontal axis, and we put s, displacement, on the vertical axis. Now, obviously we have got this restriction from 0 up to 4, but let's sketch what this function would look like if we didn't have this restriction. So I know that 0 is a repeated root. So the fact that it's a repeated root means that the graph is just going to touch that point. And I also know that 4 is a root, and the graph will go through that point because it's not repeated. So remember, we've got this negative cubic shape. So the only way of drawing this negative cubic is to make the graph look like this. So this might help us explain why we got this restriction. Well, we know that when t equals 0, the displacement 0 and the train leaves the track. Let's draw a little graph. Let's draw a little sketch of what's happening to the train. So this is when t equals 0 at the start of the track. And then let's take this as our positive direction to the right. So the train moves away from the start of the track up until this point on the curve. And then at this point on the curve, when we're at the top of the curve, at the turning point, the train starts to move back and the displacement decreases back to 0 when t equals 4. So when t equals 4, we've got a displacement of 0, so we're back at the start. And then if we were to carry on, beyond t equals 4, the displacement becomes negative, so the train would move backwards. Well, this isn't possible because we know that when t equals 0 and when t equals 4, the train's at the start of the track. So the train can't possibly move beyond the start of the track in the negative direction. So that's why we've got this restriction. T has to be between 0 and 4.